Hello learners, welcome to Sure Question Academy. Please watch the videos, like and subscribe to the channel.
Hello there. Welcome back. Today we are looking at a fantastic circuit puzzle that often trips students up in exams. Let's break it down together. Let's read part A. How would you connect 3 resistors, each of exactly 6 ohms, so that their total combined resistance becomes 9 ohms? We also need to justify our answer. Alright, let's solve part A. Think about it, 9 ohms is more than 6, but less than simply adding to 6 together. So, we'll need a mix of series and parallel. First, let's connect 2 of the 6 ohm resistors in parallel. Let's find the equivalent resistance of this parallel pair. Using our formula, 1 divided by Rp equals 1 over 6 plus 1 over 6. This easily simplifies to 2 over 6, which is exactly 1 over 3. Flipping that over, we get our parallel resistance, Rp, as 3 ohms. Great. We have 3 ohms now, and we need 9. What's left? Exactly 6 ohms. So, we take this 3 ohm combination and connect it in series with our third 6 ohm resistor. In a series connection, we just add them up. So the resultant total resistance is 3 ohms plus 6 ohms, which gives us our target of exactly 9 ohms. Beautifully done. Now, what if you preferred the other option? Let's check out your question. Here's part B. We need to calculate the power consumed specifically by the 2 ohm resistor in a given circuit. Notice the 6 volt battery, an ammeter, and 2 resistors in series. Let's solve it. To find power, we first need to know the current flowing through that 2 ohm resistor. Since it's a series circuit, the current is the same everywhere. Our very first step is to calculate the total equivalent resistance of the entire circuit. The 1 ohm and 2 ohm resistors are connected end to end, meaning they are in series. So, the total resistance, R, is simply 1 ohm plus 2 ohms, which gives us a total circuit resistance of 3 ohms. Looking at the battery, we see the total applied voltage, V, is 6 volts. Now, we can find the total circuit current, labeled as I, using Ohm's law. Current I equals voltage divided by resistance. That's 6 volts divided by our total of 3 ohms. Calculating that gives us exactly 2 amperes of current. We are almost there. The question specifically asks for the power consumed across just the 2 ohm resistor. Since we know the current and the resistance, the easiest power formula to use here is power P equals I squared R. Substituting our values, the current is 2, so we have 2 squared multiplied by the resistance of 2 ohms. 2 squared is 4, and 4 times 2 gives us exactly 8 watts. Remember to always include the unit watts in your final answer. Excellent work. Breaking these circuits down step by step makes them so much easier. Keep practicing and happy learning.